Okay, I think I'm live. Can someone confirm in the chat if I'm live or not? And if the audio is perfect. Let me know about this. Okay, we don't really have many people watching right now. That's probably because of the time right now. It's 11:30, so I don't really know how many people would like to join. Yeah, I can see I'm live. Anurag says yes, sir. Okay, perfect. Can you also confirm if my audio is also clear? Okay. And in the meanwhile, I'll just open up the problems. So we are going to discuss lunchtime today. Okay. Okay. I myself gave the dev one round. So, and I kind of like, I didn't perform like really well. But yeah, that's why like I got like 5 minutes late also because I had to solve all the previous 4 problems after that. Okay, cool. So if we go, we have to solve May lunch time, right? Yeah, cool. Yes, so you're live, audible and visual. Okay, perfect, perfect. Thank you. Okay, so if I open up dev 3, okay, can people tell like how many they were able to solve today? So we are going to upsolve the first 6 problems. Okay. The last one, my problem, we will try to debug my solution. In my solution is kind of getting a TLE. I don't really know why. Okay. I like this is a kind of a standard problem only, but I was getting a TLE. So we will try to debug this or at least look into the editorial and see like what we were doing wrong. Okay. So we will probably have the solutions of these 6 problems in this live. Okay. Also, I'm still waiting for people to tell me like how many problems they were able to solve. Okay. Let me just set up a few things in the meanwhile. Okay. Hitesh says four. That's really nice, Hitesh. I can see you're improving. Ishank says till 2 components, subtask 1. That's really nice, Ishank. I remember in the first team you said you only solved 1 problem. Okay, that's really nice, Ishank. Until case Abare first Asamra says that's also nice. Okay, that's really nice. Okay, I'm just waiting for a few more people to join. Okay, and then we'll start and kind of setting up all the things till then. Let me parse the complete problem set. And I also need to like bring my submissions also. Okay, I'll show you my submissions from this only. I was able to solve till 4. That's really nice, Hitesh. Cool, cool. Okay, since people are still joining, let me just quickly tell about what Unacademy has to offer. Okay, so as you all might be knowing, Unacademy launched 4 batches in the month of May. These are the name of the batches. One is an interview batch as well. Okay, so let me quickly guide you through like what all things we'll have in these batches. So this is regarding the samurai batch. In this batch, in the first week, so this is like the week wise detailed like structure of how things are going in that batch. Week 1 to 4 are already done. We are on week 5, I think, in that batch. Okay, so yeah, this is about that one, and let me show about the interview batch as well. This is interview batch. Okay, so in that we are actually going to start with basic and advanced interview problems. Okay, cool. Okay, so I hope like almost everyone knows all this by now. If not, like you can just have a look at all these batches, and if you feel like this is something you should like pay for, you can obviously get a subscription. Now with one subscription you actually get access to all the material, like all the batches. Okay, so if you buy just one subscription you'll get access to all the batches, and obviously you can use my referral code which is NBYT, and using this referral code you'll get an additional discount of 10%. Okay, so yeah, make sure to use this if you think like the subscription is worth it and you should buy it. Okay, cool. Okay, I think we should start. I don't really think many people will be joining today because of the timing. Okay, cool. Let's quickly start with problem 1 only. If anyone who joined late, we are actually going to solve the first 6 problems. Okay, all right, cool. Okay. So the first problem says that you and your friend are playing a game with hoops. There are n hoops where n is odd in a row. You jump into hoop 1 and your friend jumps into hoop n. Okay, you jump into hoop 2 and after that your friend jumps into hoop n minus 1 and so on. Okay, so basically what this problem says is that we have a number line, let's say from 1 to n. This is 1 and this is n. Right now in the very first turn we jump from to this position. Okay, then the other friend jumps onto this position, then we jump onto this 2, then we jump onto n minus 1, and so on till the middle. Now if you see in the question it is given n is odd, that means we will obviously come in the middle, because let's say these are x moves, these will also be x moves, and since it's an odd number, n will actually be 2x plus, in the form of 2x plus 1. So x moves will be done by us, x moves will be done by our friend, and the middle move will be done by us. Now we are supposed to tell the last move that we will do. The last move will obviously will be n, like the middle. So if we have n, the middle is actually going to be n plus 1 by 2. For example, if n is 5, then we know that if we have 1, 2, 3, 4 and 5, the middle element is 3. And if we see 5 plus 1 by 2 is actually 6 by 2, which is 3. So all you have to do is you just, okay, let me show my submission as well. Okay, and let me increase the font size. No recent activity. Why is it showing no recent activity? Okay, it is not showing me my submissions. Cool. How come? Okay, anyways, so the solution of this is just n plus 1 by 2. Let me just quickly like bring all my submissions. There is some issue. Okay, sir, I'm in basics. Will you help me how to find corner cases? Yes, Ankit, I'll definitely help you. Okay, so let me just see like why I am not able to get all my submissions. Okay, let's see if I can get through my profile. Yeah, okay, cool. So the problem name is hoop. Where is hoops? Okay, this is hoops. Okay, cool. This is the problem, not the solution. Okay, it won't show me the solution from here. Okay, just a second. Yeah, okay, cool. We have the solution now. Oh, okay. I need to go to dev1 and then open up the problem, and then I'll be able to see my submissions. Okay, cool. Okay, so this is a solution. So you just scan for every test case n, and then you print n plus 1 by 2, and that's it. Okay. So I hope this is clear to everyone. Let's move on to problem 2. And problem 2 is, let's see. Okay, so problem 2 is Tom and Jerry 1. Cool. So in this problem, we are given that there is a grid of size n 10 to the power 5 into 10 to the power 5. So as you can see, the grid is very large. Okay. Okay. All right. Cool. So we have a grid of a very large number. Okay. Let's just make any random grid. Okay, cool. Now, Tom is riding in a train currently in cell AB, and Jerry is tied up in a different cell CD. So let's say AB is here and CD is somewhere right here. So basically A is this, B is this, C is this, and D is this. Okay. Now the train has no brakes. Tied up to the cell anywhere. The train has no brakes. It shall move exactly k steps, and then its fuel will run out and it shall stop. Okay. In one step, the train must move to one of its neighboring cells, sharing a ride. Tom cannot move without the train, as the train is covered in tracks. Can Tom reach Jerry's cell after exactly k steps? So let's forget about k and let's try to find out the minimum steps in which Tom can reach Jerry. Now, if you see, there are two like coordinates. One is the x coordinate and one is the y coordinate. So we need to make our y coordinate from B to D and the x coordinate from A to C. So if you see, this is nothing but a number line, and you need to make from A to C. So the number of moves required to move from A to C will be C minus A. And similarly in the y-axis, the number of moves will be D minus P. Okay. And these will be the minimum moves, because we are only moving right and down. So we are not like first we move right and then we come left. So because of that, we are actually saving all the like unnecessary moves, and this is the shortest path. Okay. So this is the shortest path. Now, one thing to notice in this is that what if this was actually like C was somewhere here. So basically if CD was somewhere here. So this will become C. Therefore, C minus A will actually become negative. So what you need to do is you need to find the absolute value of all these. Okay. Of both these, you need to find the absolute values, so that you find the absolute difference in the x coordinate and the absolute difference in the y coordinate. and the sum of these is actually going to be the minimum like distance. Now they have given us that you need to reach Jerry in exactly k steps. But you know, let's say that the minimum distance is m. If the minimum distance is m and we in all have k steps, okay, if k is less than n m, then we say that we cannot move, so we just print no. Okay, if k is equals to m, then we can say that yes, we will be able to reach. Okay, now what about if k is greater than m? Let's say, for example, let's say that k was actually m plus 1. Okay, now in m moves, let's say cd was here only, in m moves we were able to reach Jerry. Now we need to spare one move in any unnecessary move. But if you see, if you move on the left side, you won't be able to come back because there was only one move left. If you move in the right direction, then also you won't be able to come back, and similarly for up and down as well. But if you had two extra moves, then what you would have done is you would have first moved downwards or in any other direction, and then you would have reversed that direction. So basically, if you moved down, you would have moved up. If you moved right, you would have moved left. If this, then this. If this, then this. Okay. So, and if it is 3, then also the same thing comes. Two moves can be covered using like going right and then left, but then you'll still be left with one move. Now we cannot compensate this move. So basically all I'm trying to say is that these extra moves need to be odd. So if it is 2 moves, 4 moves, 6 moves, 8 moves, or anything in the even form, then we can say that we will be able to reach Jerry, because we will reach Jerry in m steps, and then the rest of the moves will be unnecessary moves in which we'll just go right, left, left, or in any other direction. Okay, so I hope this is clear. So basically all we have to do is we first need to find these minimum moves, and then we first need to see that, okay, let me show the code. Okay, let me even open dev1 because I can only open my solutions from dev1. Okay, so we are actually on Tom and Jerry. I still cannot see my submission. There must be some issue. Okay, let me open it through my file only then. Okay, Tom and Jerry is this. Okay, cool. Okay, yeah. So basically, if you see in the submission, what I've done is I actually scanned all the values, and then I have found out the minimum distance, which is actually absolute difference of c minus a and absolute of d minus b. Okay, this is how I'm actually able to find out the minimum distance. After this distance, I see if this distance is greater than or equal to the like k. Okay, if this is less than or equal to k. So basically, if k is greater than or equal to this distance, and the difference of like k and our minimum distance is even. If this is even, then we can say that the answer is possible. Okay, so I hope this is also clear. Okay, if this is like, if this condition satisfies, we print yes, otherwise we print no. Okay, so I hope this is also clear to everyone. Okay, I don't see any yes or no's. Please like the video at least, and just say yes or no so that I know like if you're clear with the page. Okay, and with this we'll actually move on to problem 3rd. Okay, cool. The 3rd problem is birthday gifts. Okay. Okay, cool. So let's move on to problem C now. I see many yes and clears. Okay, perfect, cool. It's Chef's birthday. He and his twin have received n gifts in total. So we have n gifts. Okay. The ith gift has a price of ai. So we have prices as a1, a2 till an. Okay. Now the twins take k turns alternatively. Okay. Each has k turns. So basically first chef moves, then like let's say 1 and 2. So basically player 1 moves, then player 2 moves, then player 1 moves, then player 2 moves, and so on. Okay. And they actually make k turns. So basically the total turns will become 2k. But they have given that n is actually greater than equal to 2k plus 1. Okay. In a turn, a person may choose one gift. Okay. In a turn, a person may choose one gift. Okay. The only exception is that in the last turn of the twin who moves second. Okay. So obviously we'll have P1 and then P2. So basically P2 will move second, where he gets to choose two gifts. Okay. So basically in the last turn, P2 actually chooses two gifts. So we have two P2s. So basically we have P1 choosing k times and P2 choosing k plus 1 times. And that is why n is greater than 2k plus 1. Okay. The only exception, okay, we are done with this. Okay, assuming they both choose gifts optimally and you can choose who takes the first turn, find the maximum total cost of the chef gifts that chef keeps. Okay, so basically we need to find the cost of this P1, like the total he's able to get and the total P2 is able to get, and whoever gets the maximum value will be the chef's amount, because we'll, like, if P1 is greater, if P1 is greater than P2, then we'll say that the chef will move first, and if P2 is actually greater than P1, then we'll say that the chef will move in the second turn. Okay, I hope the problem is clear with everyone. Okay, cool. So let's see like how to do this. So a very basic thing that we have in this is that we need to first sort the array. The reason is because every like person is trying to play optimally. So if you have these pool of numbers and if you are asked to only pick one number, then obviously you will pick the biggest number. So we just remove the biggest number. So we remove like B1. Let's say B1 is the biggest number. Then when player 2 comes, he will have the complete array except B1. But if he has to play optimally, he will also try to choose something which is just smaller than B1, but the largest value in this array. So basically he'll try to choose B2, but this B2 will be less than B1. Then the next turn will be in the next turn, chef like or player 1 will choose B3, which is the highest value in the set except B2 and B1. Okay, so that is why we need to first sort the array. Let's suppose that after sorting, the array became B1, B2 till Bn. Okay, now this is the smallest value, this is the smallest value, and this is the largest value. Now what we need to do is we need to alternatively play. So we'll give Bn to the player 1. So player 1 gets Bn. Player 2 gets B of n minus 1. Now player 1 gets B of n minus 2. Player 2 gets B of n minus 3, and so on. Okay. So basically we'll have k steps here and k steps here. But then we will additionally move one more element one more element in the second player, because we know that second player gets an additional chance. Then we'll find out the sum of all these values and the sum of all these values, and then print whichever is the maximum. So if I show the code, okay, now again I'll have to go to my submission. It's twin gift. All right. So if you look at the code, okay, so this is the code. Cool. So as you can see, I just took everything in a vector. Then I sorted the vector. I have sum1 and sum2. Then I made k moves. In every move, I'm adding one value to sum1 and one value to sum2. So basically what I'm doing, I'm actually adding the last value in this vector. So if this is a vector, I'm adding the last value, which is bn, into sum1. Then I remove bn, which is v dot popback. Then I get b, the last value becomes b of n minus 1. I add that value to 2, and then I remove b of n minus 1, and so on. After k moves, the last 2k elements will be gone from this vector, and then we will take the topmost element of this vector and add it to sum2. So that is what I'm doing. I just added sum2 with v of back, and then I saw whichever is the maximum sum, we just print that value, because chef will take that much amount. Okay, so I hope this is also clear. Again, there wasn't much into this problem, and I think everyone is able to understand this now. Okay. Okay, let's move on to problem 4, which is charges. Okay, let me just close all these problems. We are on problem 4 now. Okay. Okay. So there are n subatomic particles lined up in a row. Okay, so we have n particles. Let's say this is P1, P2 till P of n. Okay. There are two types, protons and electrons. So we have protons, okay, and electrons. Okay, protons have a positive charge and are represented by 1. Okay, this is 1, and electrons are represented by a 0. Our current understanding of physics gives us a way to predict how the particles will be spaced out. If we know their charges, two adjacent particles will be separated by 1 unit. So basically, if it is 1 and 1, then there won't be any difference because these can stay together. But if it is 1, 0, then we'll have a separation of 1. So basically, we'll have a separation of one place and then we'll have 0. Okay. Okay, when Chef is not in the kitchen, he is doing physics experiments on subatomic particles. He is testing the hypothesis of having n particles in a row, and he will change the charge of a particle k times. In the ith, okay, so basically we have k operations, cool. Okay, okay, cool. K times. In the ith update, he will change the charge of the qith particle, and after each update, find the distance between the first and the last particle. Okay, cool. So let's first forget all about the queries, and let's first try to consider the initial state only, and let's take a better example. Okay, so let's say our example is 0 0 1 0 1 1 0. Okay, now let's try to find the distance between the first and the last value. Now as you can see, this is 0 and this is also 0, therefore they can stay together. Then this is 0 and this is 1. Sorry, this is 0 and this is 0, that means they need to be apart. If they need to be apart, okay, I think I messed up the definition of this in the very starting. So basically, if we have two same elements, then we need to keep some distance. If we have different elements, then they can be together. Okay, so this is the problem. Now if you see, when we have 0 0, we need to bring one spacing between these. So basically we'll add a space. Okay, now since it is 0 and 1, these can stay together. Okay, then we have 1 0, therefore these can also stay together, and then 0 1, so these can also stay together. Now we have 1 and 1, so if we have 1 1, therefore there will be one spacing between these, and then again we have 1 and 0. Now if we count the total number of places, we have 1 2 3 4 5 6 7 8 and 9, and the total distance is 9 minus 1, which is 8. Okay, now let's try to, okay, so initially we found the total distance. Now let's try to change a particle. Let's say we try to change this 0 into 1. Okay, now, okay, let's say this was, so basically this was 0 and we try to change this into 1. Now we know that since it was a 0, it actually had a distance of 2 from the left. Okay, but now since we have a 1 coming, we can say that this distance will increase from 2 to 1 and this will be removed. So basically, let's say if the total distance in the starting was this, then we can say that from the total distance we'll remove 1 minus 1, right? Then we look into the right side, which is like, we see that this is 1 and this is also 1. Therefore initially there was no distance, but now we need to add a distance. Okay, so if we try to add a distance, we'll actually have to do plus 1. So this becomes distance only. So therefore there won't be any change in the distance after changing this value. Okay, then let's try to make another operation. And as you can see, this was done in O of 1 because we only checked the left one and the right one. Okay, so we did not consume any much time. Then let's try to change this index to 1. So basically if we had 0, okay, so basically if we had 0 here and we try to bring 1 here. Now what we will say is that this 0 will say that in the left I had 1 and therefore I had no distance with it. But now since 1 is coming, I would need to make one distance. So I'll add 1 to the distance. So basically distance will be added with 1. Now in the right, it will say that initially I had 0 distance, but now since the charges will be same, I need to add one distance. So we'll add another 1. And now the total distance will become distance plus 2. So basically you need to find the initial distance in the starting, and then for every query, you need to like check the left value and the right value and see the total difference in the distance that is going to come, and then make those changes. Okay, so I hope this is also clear to everyone. Can people like give a yes or no in the chat if they are like completely clear with the approach? Okay, I'm trying to go like around the problems very fast so that the complete stream is not very long. Okay, because there will be six problems in this stream. Okay, if in case there is someone who is not able to understand, still not able to understand anything, just go back into the video a little bit and I'm pretty sure you will be able to understand everything. Okay, so yeah, let me show my code. So the name of this problem is charges, which is okay, this one. I actually wrote the implementation very like fastly after like it was like after the contest ended. I had only 30 minutes and I had to solve all these 4 problems. So I just wrote whatever came into my mind. Okay, so maybe this is not the best implementation, but this is the code that I wrote. Okay, so maybe you can have a look at this. So basically in this for loop, I'm actually finding the initial distance. So you can just look at these if and else's. There is not much to explain in these. Okay, so all I'm doing is I just check on the left side. If it is the same charge, then I add only one distance. If it is a different charge, I add 2 distance. Okay, then for every query we had k queries. So basically for every query, first I see like the index whose charge is going to be changed. Then this is the updated charge. So this is just like, this is nothing. You could have also written an if else also, like if charge of x equals to 0, then you can make charge of x equals to 1, else you can just make charge of x equals to 0. Okay, so I just wrote all of this in one line only, so you can avoid this and write the simple if else. Okay, then I just checked if the updated charge is equal to the previous charge. So basically if this one is equal to this one, then we need to add a distance. So I'm adding a distance. Okay, but if it is not equal, then I need to decrease the distance. So I'm actually decreasing a distance here. Okay, and similarly for the other case as well. So like first in the left, then we need to check in the right. Okay, so I am guessing this is also clear to everyone. We then I just print the distance for every query. Okay, okay, cool. You can just have a look at this code if you want, or you can write a better implementation also. Okay, let's move on to problem 5, which is total components. Okay, okay, cool. The next problem is total components. So in the problem, you're given all n-1 integers in the range 2 to n. Okay, so basically the range is from 2 to n. So we have 2, 3, 4 till n. Okay, this is the range, and we are given all these numbers, and the total numbers are n-1 because we left 1. Okay, now in each step you choose 2 distinct integers, and if they share a common factor greater than 1, you combine them into the same group. So basically what they mean is, okay, let's first complete reading the problem. Belonging to a group is an equivalence relation. So if integers a and b are in the same group and integers b and c are in the same group, then integers a and c are also said to be in the same group. Okay, so let's look at a test case, which is n equals to 8. So when n is equals to 8, when we have n equal to 8, the numbers are 2, 3, 4, 5, 6, 7 and 8. Okay, now the very first thing that so let's start from 2. So let's first say that every number is in its different set. Now let's come on to 3, or let's come on to 4. This 4 will say that I am actually divisible by 2. Okay, so this is the problem only. So it says that if they share a common factor, since 2 and 4 share a common factor, which is 2, we can say that 2 and 4 will be in the same group. So let's say that this is a circle and we have 2 and 4 in the same group, and 3 right now is in a different circle. Then we have 5. 5 says I am not divisible by any of these two numbers or this number. Therefore, I'll have my own set which is 5. Now 6 comes. 6 says that I'm divisible by 2 also and by 3 also. Or more importantly, I have a factor with this set also and I have a factor with this set also. So I will actually come into one of these sets, but first I need to merge these two sets because we are given that. So if this is A, this is B, and if this was a set C, we can say that A and C are similar and B and C are similar. Therefore, A and B are also similar. This is given in the problem. So basically we'll merge these two sets. Okay. When we merge, this becomes one set and 6 is added in this set. Then we have a 7. So basically 7 has its own set. Okay, let me draw it on the right. Okay, 7 has its own set, and then we have a 8. Now 8 says that I'm actually divisible, like I have a factor with 2, therefore I will be added in this set. Now if you see in the end we have 3 sets, 1 set, 2 set and 3 set, and if you see the answer for this problem is also 3. Okay, let's try to look at another like test case. Let's take a smaller one also, like if n is 4. If n is 4, the numbers are 2, 3 and 4, and we can say 2 will have a set of its own, 3 will have a set of its own, and then we'll have a set of 4 which will be included in set 2. Okay, so I hope the problem is clear to everyone. Okay, if it is, we can move on to the like solution part. Okay, so the very first thing that you need to notice is that every set will have a factor of its own. So basically in the starting, if you see, this has a factor of 2 with everyone. This has a factor of 3. But if you remember from n equals to 8, when we had like number 6 also and 8 also, and this was one set, there was no single factor which defined this. But two factors, that if there is any value which is divisible by 2 or if any value which is divisible by 3, then that will be added in this one. And if you remember from n equals to 8, there were 2 more sets which was for 7 and 5. Now if you see, every set is actually defined by a prime factor or a set of prime factors. Like this set actually has 2 and 3 as its factors. This set has 7 and this set has 5. Basically, we need to like the maximum size of the answer will be actually the number of primes till that number. So basically, okay, let's take a better example. Let's say n is 20. Okay, let's say n is 20. So we know in the starting only we can actually make a set of 2, we can make a set of 3, we can make a set of 5, we can have a set of 7, we can have a set of 11, we can have a set of 13, we can have a set of 17, and we can have a set of 19. So these are like some sets. Let me like circle them. Okay, so the maximum sets that we can have are actually 8, 3, 3 and 2. Now we need to see what all sets we can merge. Now let's write the remaining values. So the remaining values are 4, then we have 6, we have 8, we have 9, we have 10, we have 12, then we are left with 14, 16, oh sorry, 15 also, 15, 16, 18 and 20. Okay, now 4 comes. 4 says that I'm actually divisible by 2, so I'll come into this set. Now if you see, 6 comes. Now 6 says that if you factorize me, I actually come into 2 into 3. That means I'll actually merge these two sets. Okay, this set will be merged with this one and 6 will come here. Okay, now an 8 comes and 8 says that I will also come here. Cool. So now a 9 comes. 9 says that my only factors are 2 and 3, therefore I'll come into this. Then a 10 comes. Now 10 says that my prime factors are 2 and 5, therefore I will merge the set of 2 and 5, therefore we merge this and this as well. Okay, so these are also merged. Now we come on to 12. 12 says that my prime factors are 2 and 3, so I'll merge set of 2 and 3, but I see that they are already merged, so I'll just add myself 10 also and 12 also. Okay, cool. Then we come on to 14. 14 says that my prime factors are 2 and 7, so let's merge 2 and 7 as well, and let's add 14. Okay, then 15 comes. 15 says that my prime factors are actually 3 and 5, and 3 and 5 are already merged, so I don't need to do that. Okay, then 16 comes. 16 says that my prime factor is 2 only, and I will be added in a set of 2. So let me add 15 also and 16 also. Okay, now if you see 18 comes. 18 says my prime factors are 2, 3, and I see that 2 and 3 are already in the same set. Then 20 comes. 20 says that my prime factors are 2 and 5, and I see that 2 and 5 are already in the same set. So if you see, okay, all the numbers got added into the first set only, and all the values. So basically if we had 20, you see that every value which was actually greater than the half of 20 had a set of its own. Now let me tell you the reason why. Because in order to add this 11 into another set, okay, we know that the smallest prime factor is 2. So basically the least number that we need to merge this 11 with any other prime factor is 2. So basically 11 into 2 will become 22. So basically the least number that we need to merge this 11 with any other set is actually going to be 22. But since our total number n is 20, which is less than 22, therefore 11 will be left alone. Similarly for 13 as well. 13 will say that if I multiply myself with 2, I get 26. But since 26 is actually greater than 20, I will be alone in the final answer. And similarly for 17 and 19. So basically all you have to do is you need to first find the total number of prime factors, the total number of prime values till n. So basically till n, let me rub this, or okay. So basically we need to find the total primes till n, primes till n. These will be the total number of sets that we had in the start. Now I need to, okay, so now I see that n, like every number till n by 2 will come into the same set. Okay, like every prime in the till n by 2 will be added in the same set only, because every number like after that will actually contribute to that. So basically if we had 7, we saw that 7 into 2 is actually 14. Therefore when 14 comes, 14 will add 2 and 7. Similarly, when we had 6, for 6 also we saw that 2 and 3 were added. So basically till n by 2, every prime will be joined. Okay, so basically primes till n minus primes till n by 2. And this is our final answer. Basically every number after n by 2 will be left alone and will have a set of its own, and every number before like n by 2, okay, before n by 2, like every prime number will have a set, common set only, and every number which is not a prime will actually be included in that set only. Okay, sorry, I followed the same approach, but I got TLE for subtask 2. I think like you must be doing something wrong while okay, so basically I think what you're doing is in every test case you're trying to find the primes, but you need to pre-process that part. Okay, I'll show that how to do this. Okay, so I hope the approach is clear to everyone. Now there are some edge cases in this, if you see, or like we can just, so basically if n is 2, we know that the answer is actually going to be 1. Okay, but primes till n is 1 only, that the number of primes till n are 1 only, and primes till n by 2. Okay, or maybe, so basically we need to just hard code that for n equals to 2, the answer will be 1, and for n equals to 3, the answer will be 2. Because for n equals to 3, basically n by 2 is actually going to be 1. Okay, sir, I didn't do pre-processing, prime factorization is required. Yes, if you didn't do pre-processing, then you will obviously get a TLE. Let me show my code and you can see from that. Okay, so the name of this problem is numconf1, and if we look at numconf, okay, why am I not able to find this problem? Okay, let me just show my code. Shivanshu has said that this problem showed wrong even though it was so simple. Maybe you did not write the edge case. Okay, so if you see, so basically this is a very general sieve code which I'm running till 10 to the power 7. The reason is that if you see, n is actually till 10 to the power 7. So basically we need to find the count of all primes till 10 to the power 7. So basically what this sieve does is it actually stores like all the prime values. Okay, so basically my prime of any index, so basically my primes in this code, my primes of x will actually tell me if x is prime or not. If it is prime, then the value will be 1. If it is not a prime, then the value will be 0. Okay, so this is what this pre-processing is doing. This is a very common code of C of error process, so you can just Google this up, or maybe like look at my submission only. Okay, and what I'm actually doing is I'm actually calling it on the very top. So I'm pre-processing this before scanning the test cases, so that for every test case I do not do this, because this actually takes the complexity of this is actually O of n log of log n. Okay, so but since n is actually 10 to the power 7 and number of test cases are I think 10 to the power 5, therefore these will get multiplied if you do it inside the while loop of test cases. So you need to first pre-process all the prime numbers and then like do everything. Okay, then I just scanned all the, okay, before that I actually made a prefix array of these primes, so that till n I can have a count of all the prime numbers before this number. Okay, so that is what I'm doing in this for loop. Then I just scanned all the test cases. I have this edge case written here, and then I just printed 1 plus primes of n minus primes of n by 2. Okay, okay, I have used C but doesn't made that prefix vector. I have made vector of primes, that's why it is giving TLE in subtask 2. Okay, yeah, so that is the reason it is giving a wrong answer, Ishank. You could have like added, like made a prefix also. Okay, so I hope this is also clear to everyone. Okay, I missed only for 3 getting wrong answer. Yes, this is an edge case that you need to include. Okay, I hope this is clear to everyone. This problem is also clear to everyone, and we can move on to the next problem. They say yes, sir. Okay, perfect. Okay. Okay, and also I'll like, can you explain prime number once? So actually it will take a little time to explain this. This is a very general code, and it is known as sieve of erostosis. Sieve of, and I don't really know how to spell this eros. So okay, let me just Google this up and show it. Sieve of, okay, this is the name, ERATOSTHENES. So you can just Google this up and like look at this algorithm. Okay, this is a very general algorithm and everyone should know this. Okay, all right, so this is also done. Let me close all these problems. Okay, now let's move on to which one. Okay, okay, let me open div 3 as well. No, not June challenge. Complexity of that is n log of log n. Okay, this is the complexity of sieve of erostosis. Okay, let me go to div 3. Okay, cool. Okay, let's go to case subarrays. Okay, now I'll explain case subarrays. Actually I myself was getting a wrong, a time limit exceeded for some particular reason. So I'll even like look at the editorial right now only, and I'll explain like what mistake I was doing. I'll first show my code and then like try to explain like what wrong I was doing. Let me open the editorial only and I'll explain it in a minute. Okay, let me just first explain the problem and my approach. So basically what they're telling us is that you're given two integers n and k. So we have n and we have a k. Okay, and an array of a of n integers. You have to choose k disjoint non-empty. Okay, so basically we are given an array of n integers. Okay, so this has n elements. Okay, now we need to partition this complete array into k subarrays. Okay, and so basically we need to find the total score, which is actually going to be summation of from I to 1 till k sum of subset subarray I into I. Okay, where sum I denotes the sum of elements in the ith subarray. By this ith subarray, we mean the ith one in the order from left to right. From the maximum score that can find the maximum score that can be achieved. So basically, we need to partition this complete set into k subarrays. So let's say this is partitioned like this. Let's say k is equals to 3. Then we partitioned it like this, and then we need to then we need to take some elements from this, a subarray from this, a subarray from this, and a subarray from this. Okay, and find this value. So basically find the sum of first subarray, second subarray, and third subarray, and then find the value of this. And we need to maximize this thing. Okay, can I solve birthday gift question of div3 using priority queue? I don't really remember what birthday gifts had. Okay, I'm pretty okay. Just a second, let me see only. Birthday gift, I don't remember the question. The question had, yeah, you can solve it using priority queue. You can easily solve it using priority queue. Okay, so I hope the problem is clear to everyone. Okay, now before solving this problem, let me try to explain another problem. Okay, so there is a very general dynamic programming problem known as partition. I think it is known as painter partition problem. Okay, so basically you have a array of n, size n, and now you need to divide the subarray into k subarrays, k parts, such that okay, we need to divide. Okay, such that the product of, I don't really remember the problem. Let me just Google it. Painter partition. Okay, this is a very general problem, I think, of okay, cool, understand. Okay, cool. So basically what you need to do is you need to actually divide these k subarrays. Okay, and let's say you had to find any particular value in every subarray. Okay, so what you could have done is that you actually wrote to dp of, okay, do I need to explain the, okay, let me first explain subtask 1 and subtask 2, and then I'll come on to this. Okay, first let's see subtask 1. In subtask 1 we are given that k is equals to 1. Okay, now if k is equals to 1, then we can say that in this complete subarray we need to remove just some elements, such that in this complete array I just need to find one subarray which has the maximum sum. Because if I have this will be sum of one, sum of the first subarray into 1, this will be my score. So this one has no significance. I just need to find out the maximum subarray sum of this. Okay, and this is actually a very famous question known as cadence algorithm. So maybe if someone didn't know this, you could have just you can just Google it right now and learn about this approach. This is a very standard interview problem. Okay, so in order to find the subarray in an array which has the maximum sum, you need to use cadence algorithm. Okay, so you just had to implement this cadence algorithm and you would have got an AC on subtask 1. Okay, now let's look at subtask 2. Now in subtask 2, for k equals to 2, we are given that there might be two subarrays. Okay, now what you can actually do is, if this was a subarray, you can apply the same cadence algorithm from the left side first. And let's say we had another array, left cadence. Okay, left cadence, or let's say this is left only. Okay, and in this left array I'm actually storing the maximum value of any subarray till this index, till this index from the left. So basically first I take this subarray only and try to find the maximum sum in this subarray, then I try to consider this subarray, then I try to consider this subarray, then I try to consider this subarray, and so on from the left. So basically my left of I will give me the maximum sum from 0 to I, and I do the same thing for right as well. So basically my right I will now give sum from I to n. Okay, so basically, yeah, Hitesh wrote prefix and suffix cadence. We can see that. Okay, so basically we have two subarrays, one is left and one is right. Let's say this is right. Okay, this is right. Now what you can do is you can actually fix one partition and say that this is my first subarray and this is my second subarray. the answer of the left one will be written here and the answer of right one will be written here. So basically you need to like find the maximum value of, if you see, find the maximum value of left of I plus right of I plus 1. Okay, and with this you'll find the like maximum sum for k equals to 2. I can even show you the code for this one because I coded for every subtask. Okay, okay, I'm not able to find my submission here. Just a second. If I go on to my profile, which I can find through. Okay. So if I go to my profile, I'll find the submission of. Okay, next. Okay. Come on. Okay, so if you see for 50 points, this is a submission. And let me show for cake subtask 1 as well. So for subtask 1, all I did was, okay, all I did was I just made hard coded that if k equals to 1, this is the algorithm of Cadence algorithm. So you can just look at this and then I printed the maximum value. Then for subtask 2, what I did was I actually made a left array, which is left n. So basically for k equals to 1, this is written. For k equals to 2, what I do is I make an array of left n and I store all the values in left I. Then I do the same thing for right n. I do the same thing in right I equals to this. Then I just run a for loop and find the maximum value of left of I minus 1 plus 2 into right. So basically left of I minus 1 plus 2 into, because we also need to multiply I. Okay. So with this, you can actually find for k equals to 2 as well. Okay, now one thing you need to notice is that maximum so far should be written as minus infinite. The reason is because if you look at the problem, we have negative values as well. So basically there might be a case that all the values in the array are negative. Then you will have to take one value at least. Okay. Okay, so this is also done. Let me explain for the third subtask. Okay. Where is the third subtask? Where is the problem? Okay, now if you look at this third subtask, you actually need to, okay, let me make a, okay. Now we already know the pattern. I'm assuming that everyone already knows the painter partition problem, which actually says that in dp of ik, ij, we can store the like, so basically, so in this we can actually store how to partition, okay, how to partition n minus I elements in j paths. Okay, so we just write a very generic dp in which if we are at this index, then we can already know that how many like what is the value, whatever value we are trying to find, if we try to divide the rest of the array in j paths. Okay, then so basically in every like sub array you just have to run a cadence algorithm. Okay, one is this type, or the other type is actually you can have a segment tree as well. So but I think that might give a TLE, so I actually implemented it using cadence only, but I myself got a TLE. So let me just look at the editorial. So if we go into the editorial for subtask 1, 2, subtask 3. Okay, this is the DPIJ that we have written. Okay, to find the maximum we need to just a second, let me like try to understand this part. I think I missed this part. To find the maximum. Okay, as we can see that when we start a user value. Okay. Okay, cool. Okay, cool. That is really nice. So basically, one thing that we missed is that it is not necessary that like we only need the value of dpij. We might also need the value of dp of I plus 1 comma j, because the case is that we might have skipped I plus 1 only, that we do not use this in any subarray, and we try to find the value of this only. So basically, to find the value of dpij, we actually need like the maximum of dpij, dp of I plus 1j, dp of what, I plus 2j, dp of I plus 3j, till the last value. Okay, like till the end. Okay, and to find this, we'll actually have to run a loop of O of n. So to like remove this part, we can actually like have a prefix of all the previous dps. Okay, so that is something I missed. So I'll add this to my code. If someone wants my code, they can like find on the Discord group. Okay, I'll add this part to my code and then print, like post the code there. I hope this is also clear to everyone. If not, you can just read the editorial, or first look at painter partition problem. That will actually give you an idea of how this dp is written, and then you can like see this prefix part. Okay, all right, cool. So I hope this is also done. I'm not very sure like how many people were able to understand this, but yeah, the prerequisite of this is like knowing dp states and knowing the painter partition problem, and then only you can do this part. Okay. Okay, then let's move on to problem. Okay, where is, okay, I can even explain interactive mst, and in this I can explain like the first two subtasks if anyone wants. I was able to like solve the first two subtasks. Okay, so like is there anyone, okay, I think we should like leave these, because I don't think like people in dev 3 are really interested in knowing the solution of this. This is an interactive problem, and it's actually, the problem with this question is that it's a little hard to understand like what the problem says. After that, like the first and second test case are very easy. Okay, so I think I should end the stream with this, and I hope everybody is now able to like do the first 5 problems at least, and for the sixth one you can like look at the editorial, or like I maybe some of you were able to understand with this as well. Okay, okay, I think it's time. Pradeep says hello. Okay, cool, cool. Mutla says explain, sir. Can you tell me like what you're like asking me to explain? Please explain, sir. Can you tell me, Mutla, what you're asking me to explain? Okay, I see Anurag also asking me. Yes, sir. Explain. What are you trying to ask me? Last question. Okay. Okay, I'll just explain the problem. Okay, what the problem means, but I don't really. Okay, I think it's better to leave. Okay, let me just like explain what the problem is saying. Okay, so I'll not read the problem, I'll just explain it. So basically, the problem says that we are actually given n nodes and images. Okay, now let's just say that like this is an edge, like this is u1 v1 u2 v2. Okay, we have u0 v0 u1 v1 u what is, okay, not even this. So let's just say like these are some edges, these are some edges. Okay, and let's call this as e0, this is e1, this is e2, this is e3, this is e4, and this is e5. Okay, now all these are actually arranged in a permutation. So let's say that, let's write a permutation. Let's say that in the very starting we have e2, then we have e0, then we have e5, then we have e1, then we have what, e4, and then we have e3. Let's just say that this is one permutation of these edges, and this is something that we are already given. Now what the problem says is that in every query we can actually give them, so for basically for every query, in every query okay, in every query I'll actually give them like m number of weights. Okay, so I'll give it w0, w1, w2, w3, w4, W5, W6, oh sorry, W5. Okay. And basically what this means is that they are actually going to assign all these weights to these edges in this permutation. So basically W0 will come here, W1 will come here, W2 will come here, W3 will come here, W4 will come here, and W5 will come here. So basically edge 2 will have a weight of W0, edge 3 will have a weight of W1, edge 4 will have a weight of edge 0 will have a weight of W1, edge 5 will have a weight of W2, edge 1 will have a weight of W3, and edge 4 will have a weight of W4, and edge 3 will have a weight of W5. So these are basically the edges and these are the weights now. Now what they're actually going to do is, what the judge is actually going to do is, so let's just say that using these edges a graph was made. Okay, let's just say that this is a random graph. Now the judge is actually using these weights. So let's say this is E0. If this was E0, then the weight will be W1 here. If this was E1, then the weight will be W3 here, and similarly. Now the judge is actually going to find the minimum spanning tree of this. So let's just say that after minimum spanning tree, okay, let me just assign all these edges. So this is E0, E1, E2, E3, E4, E5. Let's just say this was the complete graph. Let's say, and the weights became W1, W3, then we have W0 here, then for E3 we have W5, for E4 we have W4, and E5 we have W2. Okay, then let's just say that after the chef tried to find the minimum spanning tree of this. Now as you can see, there are only, okay, this is a tree only. Okay, so basically only one node edge will be removed, and let's say that the edge removed was E2. Okay, and as you know that minimum spanning tree is actually found using considering the weights. So let's say that E2 was removed. What the judge will return is, it will return all the edges that were used in the minimum spanning tree except E2. So it will return E0, E1, E3, E4, and E5. Not the edges, it will actually return me the indexes. So basically it will return me 0, 1, 3, 4, and 5. So basically it is going to return me n-1 numbers. Okay, so if, like, as in this we have 6 nodes. Do we have 6? 3. Okay, there is one edge missing. Okay, anyways, so basically we'll have n-1 numbers. Okay, so these are the numbers. Okay, and only 2 is missing. And even this can be in any order. It is not necessary that this will be in any sorted order or anything. We are supposed to find out do m queries only. And after the end of m queries, we need to return the this permutation. Okay. So I hope the problem is clear. If it is not clear to anyone, you can just go back in the video and watch it. Because I don't think it will be better for the other people to explain it again. So you can just go back and try to understand the problem. Okay. Now, I hope everyone is understanding this by now. Now, there are separate test cases. Let's look at subtask 1. In subtask 1, we are given that this is a tree. So basically this graph is already a tree. Okay. Now the very first thing that you can see is that if this graph is a tree, then we can say that in a tree, the minimum spanning is itself a tree only. Okay. So basically when you actually find the minimum spanning tree, you will have to return all the edges. Because in total only we had n-1 edges, and the minimum spanning tree needs n-1 edges. Okay, so if you see, no matter what query you do, your result will not change. Every result will have all the values, and therefore there is no way you are able to find the permutation. So basically the answer for this will be -1. For every case, you will have to print -1. But there is an edge case. What if n is equals to 2? If there are 2 nodes, if this is 1 and this is 2, then there is only one edge possible and the permutation will only have one only. Okay, so basically this is one edge case in this. Let me open up my code as well. Okay, interactive MSG. Okay, it is not. Okay, just let's give it some time. It is not loading. Oh, okay, anyways, the answer for if it is a tree, so let me write it here. If it is a tree, the answer is going to be -1 For n equals to 2, the answer is actually going to be called like 0 only, because there is only going to be one edge. Okay, so I hope the tree part is clear. We'll have only two cases, like if it is n equals to 2, we just print exclamation mark 0, otherwise we print no, not no, we print -1. Okay, let me okay, it is not able to open. I think CodeChef is like getting very less responsive right now. Okay, anyways, let's move on to the second subtask, which is when this is not okay, it is opening now. Okay, let's wait for a minute. Okay, so if you look at this, if you see, if n equals to 2, I'm just printing exclamation mark 0, because there's only going to be one permutation, which is like 0 only, so we can print that. If it is anything other than 2, then we can say that there is no possible, like no specific permutation possible. Okay, now let's come on to the second subtask, which says that this like the given graph is actually a cycle. So if this is a cycle, if you actually look closely, if we actually have a cycle of this, if there are n nodes, then there will be m edges. Okay, and since the judge is supposed to find the minimum spanning tree of this, if we actually try to like label these as, like, let's say the weight of this is m, this is 1 1 1 1 and 1 and 1. When the judge tries to find the MST of this, it will only remove this edge. Okay, and it will return this edge, this edge, this edge, this edge, and this edge. So basically what I'm trying to say is that we will first assign the very first edge with the weight of m and all others with the weight of 1. The judge will return all these values. It will return me 0, 5, 1, 4, and 3 in any order. And what I'll do is I'll actually run a loop from 0 to n and see which value is missing. Whichever value is missing is actually the first value in the permutation. Then in the next iteration, what I do is I actually do the same thing. I have 1 here, but m on the second permutation value in the permutation, and then 1 for every other case. Now the judge is actually going to return me every index except this one. So I'll have 2, 5, 1, 4, and 3 in any order. Okay, only 0 will be left. So I'll again run a loop and try to find which index is missing, and then I'll say that in the answer permutation 0 is at the second index. Then I'll similarly do for every edge. Okay, now there is one thing. So basically, let's say we are done till this index. So for 5 indexes we know the answer. Now if we know the answer of 5 indexes, we can directly find the answer of the last index. Okay, because in total we can make q queries only. Okay, so if we make all the q queries in finding the permutation, we will not be able to print the answer. So we need to save one query for that answer. Okay, so basically by using m-1 queries, we were able to find the complete permutation. Now in the last query, we can just put some clarity in the process. Okay, in the last query, we can just print the complete answer. Okay, so let me just show the code. Okay, so if you see, basically what I'm doing is for t1 equals to 2 for second subtask, I'm actually scanning all the test cases, then NNM, then I'm making a visited array. So basically in this part, I'm actually asking the query. So as you can see, if my I equals to j, I is running from 0 to m-1. If my I is equals to j, then I print m, otherwise I print 1. So basically first it will print m1111. In the second case, it will print 1 m and then 111 and so on. Okay, after printing these, I scan. Okay, and while scanning, I just mark every node as visited, whichever edge I get. Okay, then after that, I just see which was the edge which was which had it's visited as 0. If it is 0, that means this was not included in the judge's answer, and hence we can say this is the ith index of our permutation. So I just push this. This v is actually my answer. So I just push this very index into my v. Okay. Okay, after coming out, so basically I make m-1 queries like this, and I'm able to find till the second last index. After that, I do the same thing. I just look into my own permutation and try to see which value is missing. Whichever value is missing, I just push that value into my answer vector, and then I just print my vector. Okay, so I hope this is also clear. So basically, the idea is very simple. It's only the understanding the problem. It took me also it took me 15-20 minutes to understand the complete problem. So yeah, you just had to understand the problem, and then like subtask 1 and 2 were easy. I don't really know how to solve subtask 3. And after that also, if you look at tokens of a tree also, I actually submitted a code which would run for subtask 1 and 2, but somehow I was getting a wrong answer, so I won't explain it. But yeah, okay, so let's close all the problems, and I hope this is enough for today's stream. Okay. Okay, I am going to end the stream now. Thanks everyone for watching. And just like the video if you like